Welcome to This Is My Architecture. I'm Matt from AWS. Today I'm joined by Jason from Logicworks. Thanks for joining.
Thanks for having me, Matt.
So tell us about Logicworks.
Sure. Logicworks is a managed service provider. We've been a AWS Premier Partner for going on about 5 years now and working with AWS since 2012.
So you work with a lot of heavily regulated customers, is that right?
That's right. Our focus is really compliant industries and specifically healthcare and financial services.
Okay, so looking up here on the board, I see what looks pretty much like a 3-tier application, but given that you work with heavily regulated customers, I imagine that the devil's in the details, is that right?
Indeed it is, and you're not wrong, it's a 3-tier application. We did, however, this was a on-prem application. The requirement was to move it into the cloud. It was a HIPAA compliant application, so we had to adhere to the requirements of the AWS BAA and also just in general best practices around security and compliance in the cloud. And we're able to do so for the most part traditionally, but there's a couple of big gotchas with this app.
Okay, well let's dive right into the gotchas. So you said HIPAA compliance, so I imagine this is a healthcare company. Tell us sort of what requirements you had to meet for this customer.
Sure. I mean, in general, a lot of these are pretty familiar. So we have a internet-facing, web tier.
Yeah.
Up here. We have a EC2 compute tier here, and I'll go into this more detail. And then we have a traditional RDS database, relational database on the back end.
Yeah.
So some of the first requirements we hit were that the actual users actually needed to whitelist the endpoints in their firewalls for egress.
Okay,
right?
so that's not necessarily a HIPAA requirement, but that was a customer requirement?
That was a customer requirement, exactly.
Got it.
Which is not that big of a challenge, and a lot of the kind of older, traditional on-prem things will operate that way. The challenge for us was that in most of the cloud load balancing solutions, that first kind of layer of load balance is taken care of by DNS records that do that, right? So the challenge there was solved pretty quickly by the fact that AWS had recently released the NLB, the Network Load Balancer. So the Network Load Balancer allows us to put public fixed IP addresses in that public availability zone, keep the rest of the applications secure and private in private availabilities or private subnets, and have those IP addresses be fixed for whitelisting.
Okay, so because with NLBs you can put public fixed IPs in public subnets, it allowed you to do that whitelisting, whereas you couldn't do it before.
Correct.
Okay, interesting. All right, so now I understand why you have an NLB here. What happens next? What's going on with this EC2, what looks like an auto-scaling group there?
Yeah, it's exactly what it is. Although the reason that we had to put it there is the real big gotcha with this application.
Okay.
So we're all pretty used to working with SSL and SSL termination, particularly in compliant environments, right? So traffic will come in, will hit your load balancer, it gets passed down to the web tier, right? And typically we can do SSL termination up here, and then use self-signed certs or some other method of getting it back here, obviously always adhering to encryption in transit. The challenge here was, if this is our app layer down here, we need to terminate on day one 10,000 SSL certificates in this environment.
And that's day one, I assume that
that's
means
day one.
many more
so
later.
Day N, it's going to be 30,000 or even north of that.
Okay.
Right? So that was just a peculiarity of this application that the client came to us to help find a solution for. So what we did here was we quickly realized that NLB or an ALB was not going to be a solution because of the limitation of 25 SSL certs per ALB, ELB. I believe that can be requested, the limit can be requested, but
not
obviously we're orders of magnitude outside of where we need to be, right?
Yeah.
So what we did there was we introduced a HA proxy tier, which handles the actual SSL termination for requests that come in. So the HA proxy tier is an auto-scaling group, right? So that's largely for availability. So it's a fixed size, but if one goes down or there's an issue with one, it's automatically replaced and repopulated and able to service again. And that way we can terminate our 10,000 potential SSL connections at this tier.
Interesting. Right? So to get around the limitation of the number of certificates that you can terminate the load balancer with when you're using an ALB or an NLB, instead you used an HA proxy cluster to terminate tens of thousands.
Exactly.
Okay, interesting workaround.
Yeah.
That's cool. Okay, so NLB flows into this cluster, and then what happens next?
So obviously we're not where we need to be yet, right?
Yeah.
Because we haven't reached our actual app tier down here. So from here, what we'll do is send the connection through another load balancer, right? Because we need to make sure that we can have multiple app servers back here.
Got it.
So those are lined up behind another load balancer.
Okay.
So in this case, you'll notice that despite the fact that the ALB, the application load balancer, was released about a year ago, maybe at this point, and has many more capabilities than the traditional ELB, we're actually using an ELB here on purpose. And that's because these listeners are all in TCP mode. Because we're basically passing that encrypted traffic through the ELB to our app nodes on the other side. So we need to take advantage of TCP node to be able to do
Well, you took the words right out of my mouth because I was going to ask why aren't you using an ALB here, but that makes sense because you need to take advantage of TCP mode to pass through. Okay.
Exactly. Now from this point, it's really straightforward. Now we pass on to our app tier, and this is a traditional EC2 compute tier for the application stack.
Great, and then down here I see RDS. Does this represent a master slave?
It is exactly a master slave, and then we can also do reporting off of the slave where necessary.
Great, so encryption everywhere, the special requirement of the whitelisting of those sort of public IPs, the HA proxy layer to handle the tens of thousands of termination. That's, really you're meeting the HIPAA requirements, meeting the special requirements of the customer really elegantly, and so preserving the three-tier architecture with some little tweaks to make it HIPAA compliant.
It's 3.x tier.
Very cool to see. This is a great architecture, and I appreciate you sharing it with us.
Great, my pleasure, Matt.
And thanks for watching. This is my architecture.